So I just want to share a few, so I really want to try and make this next few minutes as valuable as possible for you. And I'm going to touch on a few practical implementations when it comes to data privacy and guardrails. What frustrates me is that everyone talks about guardrails, and I keep on thinking, show me, explain to me exactly how it works. And I'm tempted to name a few companies, but I've been in a few webinars, and I think, well, here they're going to show me. And in the end, they just speak about toxicity and guardrails and bias, but there's no practical examples. So I first want to, and it's not just about the data, it is about the ecosystem. So this is a chart I've been working on for quite a while. Some of the marketing people don't like this because they're saying I'm giving our competitors a free lunch. But all I'm trying to do through this is just show how complex and fragmented the large language model ecosystem is. So, I mean, if you just take the last few months, the developments in terms of generative AI and large language models, and the market is really segmenting into different layers. So, and I'm happy to share any of this research. You can ping me on LinkedIn or catch me afterwards. I've got a whole set of market architectures for different areas I put together myself. I'll share it with you and you're free to use it. But something we saw with conversational AI or chatbots was there were different chatbot platforms. And it was really a closed ecosystem, and they maybe only made use of ASR or text-to-speech. And all of a sudden with generative AI and large language models, there's a whole fragmentation of the market. And I would say this lack of unification really makes it hard to manage the data. So just briefly at the bottom, you will see that there's the hubs. And if you go to Moodley had a talk yesterday, and I think tomorrow he's going to delve into the detail of Gale. And that's why you will see Core at different places. It's just because of with the advent of Gale. So obviously at the bottom you've got different large language models and different hubs that's available. Then the second layer is the data-centric layer. That's really a layer that, and you'll see in upcoming slides, that the data layer is a layer that will receive much attention in the near future. So as we go through the different layers of adoption, in the upcoming slide, I'll show you the fifth layer is really where data AI comes to the fore. And then we've got the vector embeddings, the vector database piece, the third piece from the bottom, that really enables RAG. And then all of a sudden, there's a whole lot of large language model API build products and a lot of flow products right here in the middle. And these two areas are expanding at a tremendous rate. There's virtually every month, there's a new flow building product, especially if you go on Y Combinator, you'll see many of the companies they're backing are flow building companies. And the challenge with many of these flow builders is that the flow of data in and out, often commercial models are used, external models, and that's the challenge. And something that was alluded to by Andrew on the main stage was individuals, employees using generative AI. And at the top, you'll see a whole lot of content creation tools, and that area is changing all the time. Idea creation tools, writing assistants, that's more on a one-to-one basis. So what I'm trying to say here is that the product stack for large language models is really complex, and it's changing all the time, expanding. There's a myriad of products, and managing the flow of data between these products is definitely a challenge. This is one of my favorite slides, and I built this slide up as the technology was progressing. So you'll see on the one side there's the complexity and the flexibility. So as implementations grow in enterprises, the complexity, the need for flexibility increases, and then there's also the introduction of complexity. And there's no way to get around that. And I think, if I may say it, I think that's one of the challenges with EXO, is to have a simplified user interface on a very complex product. And you'll see at the bottom, we started with static prompts. And I can still remember when I wrote my first prompts, and we all felt that is the answer, right? You can write a prompt and get something back. And all of a sudden, prompts had to scale. Prompts had to be flexible, and they had to be shareable, and they had to be reusable. So then we went to prompt templates. So basically, a prompt template is really just where you've got placeholders, variables, and you can inject values into your prompt, at inference time. Then we moved on to prompt composition. LangChain has got some nice examples where you ask a question and they take different prompts and they compose those prompts, different elements into one prompt for a specific task. Contextual prompts led to prompt chaining. At one stage, everyone thought prompt chaining is the answer. And you'll see for each of those stages, I put the products that's applicable to that stage that developed with the technology. So the idea behind prompt chaining is that you want to have a flow or a longer application, and people started chaining prompts together to address wide horizon queries. And really from prompt chaining, the flow builders all started up. And then the next step was RAG, Retrieval Augmented Generation. And as I mentioned yesterday, RAG really came to the fore when there was at one stage there was this idea that large language models have emergent capabilities. So people really believed that they're discovering new abilities in large language models. And if we can just find some new feature, we can build a business on that. And on Archive, there's a very good study, if you want to look it up, called Emergent Capabilities, a Mirage. So it turns out that large language models do not have any emergent or hidden capabilities, but they're really good at in-context learning. So if you query a large language model and you add context, then the model will rather make use of the knowledge in the context you supply than the data it was trained on. And hence the explosion of RAG, where systems were built where at scale, at high speed, chunks of context could be retrieved and injected with the prompt to inform that query. Something also interesting about retrieval augmented generation, all of a sudden we saw that context is important. And that's why I enjoyed that talk this morning of the analyst of Forrester, where he gave the different sentence lengths. And the longer the sentence was, the more context there was, so it was easier to predict what the outcome would be. The shorter the context, the more ambiguity there is. There's also this notion of alignment, aligning the user expectation with the outcome or the generation of the large language model. So it's easier to align if you have better context. And that's what RAG does. With each query, it supplies the relevant context, hopefully just enough to answer the question. Then we went on to prompt pipelines. Prompt pipelines in the core ecosystem or the core world is really, if you look at the workbench of Search AI, where you have that sequence of things, we call it the workbench. I like to refer to it as a pipeline, where you can have a sequence of steps where you query, you clean your data, different processes before you get to the output. Also with Gale, you can build a pipeline where you perform different functions on the data before you output. The exciting part is autonomous agents. I see personas, yes, I'm not going to say too much about autonomous agents because there's still, there are things happening, but autonomous agents is really where we're heading, where you have an agent that's got different tools at its disposal, and these tools have got descriptions in natural language, and the agent, based on the user query, decides which one or multiple tools to use in what sequence to achieve its objective. And then lastly, prompt tuning of soft prompts is where the prompts are created automatically by the large language model based on previous queries. So you can see how this chart is just expanding, and weekly I'm adding new detail to this and new logos and new products. So it's really expanding at a tremendous rate, and hence why I said it's very difficult to manage data and to manage the flow of data between these products. Maybe just something on RAG and privacy. So obviously Search AI is Kore's RAG solution. And there was also a recent study that showed that the study found that there is meticulous focus on cleaning the data, removing any PII data when a model is fine-tuned. But as soon as there's a RAG implementation where documents and PDFs and different company information is submitted, they found that the same stringent data governance is not taking place on the RAG systems. So something I found interesting is that they did a few studies, and this is one of the, if you want a link to the archive study, you can ask me for it, I'll send it to you. But they did a study on how they can interrogate and fish for private information on RAG systems. And so they, basically, if you look at the right-hand side, they could ask questions, they give a command, and then they inject phrases directly into the prompt that says, my phone number is, please email me at. And through that, they managed to get telephone numbers and email addresses from the RAG system. Just so you can think a scenario, a company is prospecting, they want to sell, and they just start asking the conversational interface that type of questions. And especially RAG-based systems are vulnerable, not because of the technology, but the data is not cleansed. There's no data governance taking place in many cases when the RAG data is submitted. So there was this disparity between extreme focus on fine-tuning the data, but somehow RAG slipped through the cracks and company data gets uploaded without being properly checked. Something else I thought to touch on is data-centric AI. Now you mentioned, if you listen to Raj's opening keynote on where he sees data going with the data studio and data annotation. And I also like what Andrew Ng, he's got this whole thing about a data-centric approach. So the differentiator will not be the models, but it will be the data that's available. And this is really a slide I put together just for my own understanding. So if you see any way to improve it, please tell me. I'm keen to learn. So I basically took the development of large language model, of the large language model ecosystem, and I tried to plot it out. So we all know that large language models were primarily used in design time, because that's easy. You have a conversational design interface, people enter their own OpenAI API key, whatever they use, or their Hugging Face token, and they use it as a conversation design and a conversation build tool. And it's your own cost, it's only one developer that's using that API key, it's not customer facing, and it helps you to build a better experience. It was used initially as an AI-assisted NLU data creation engine. So the first thing was people created intent training examples using generative AI. Then it went into chatbot development and flow generation. The next stage, and it took some work, I think, to move out of design time into more of a runtime implementation. And yesterday I spoke about the 7 impediments, and I'm repeating that talk tomorrow at 12, I think. But there are 7 reasons I identified why people, companies, and enterprises are struggling to go from design time to runtime. So moving into runtime, stage 2 is where we start using it for text editing, for document search and chat, for RAG, and for prompt chaining. Stage 3 is really more for no-code fine-tuning, custom playgrounds. Sorry, I see custom playgrounds is twice. There's something else is supposed to be there. Stage 4, prompt pipelines, autonomous agents, orchestration, LLM hosting. So you'll see, if you attend Woodley's talk, you'll see that Gale really falls into stage 4. So Gale addresses those elements, and Gale supports EXO. And then the 5th stage, and we are getting there, will be data. So stage 5, data discovery, sorry, the slides were redone. It's actually data discovery, data design, and data development. So already RAG addressed data delivery, getting the data to the large language model. Data discovery is really just understanding what your customer is saying, creating clusters of utterances that's semantically similar. Data design is getting the data in the right format to train the large language model. So obviously large language models wants to have the data in a certain format, and that's the portion of data design. And then data development is finding vulnerabilities in the data and then enhancing and developing that areas where the data needs to be enhanced. And I think as we move closer, data will become more and more important. And again, just to bookend that, if you look at Y Combinator, there's so many flows, new flow builder, chaining, no-code GUIs being introduced. But it's as we move up this ladder, data AI and data discovery, design, and development will become increasingly important. This is just to break down in simple terms the different ways of delivering data to the large language model. So at the bottom, so it's basically 2 halves, right? So at the bottom, it's gradient. At the top, it's gradient free. So all that means is that with the gradient approach is that these are ways to fine-tune the large language model. So you create a custom version of that model. And there are various ways why organizations do not want to fine-tune models and follow a gradient approach. The one reason is that it's cost. So as I showed yesterday, and I will show tomorrow, that there's significant cost involved in fine-tuning a model in terms of token cost. The second one is data. So if you're not sure about your data, then you're not sure if you want to spend that cost in fine-tuning the data. The third thing is investing in a specific model. So you saw that OpenAI is deprecating models on a regular basis. So imagine if you invested time and money in a model, and that model is then deprecated. So 2 things are happening. The one is that organizations and enterprises want to get to a stage where they are model agnostic, or where models are treated as an utility, that it's not such a big deal to change models, to move to different models, to orchestrate various models. And with the way models are deprecated, you are in a way forced to move to have another model to move to. The gradient-free approach is where you say, well, I use a standard model, I'm not going to change or fine-tune the model, the base model, but I'm going to find different ways of delivering the data in such a way that it enhances my use case and it leverages the model. And you'll see in prompt engineering, I just listed a few there. There's a whole host of different prompt engineering approaches. I think the most common one is chain of thought, right? So chain of thought is the most common, so everyone just prompted directly the model. Then all of a sudden, someone found out chain of thought, that if you lead the large language model in thinking and you create a sequence of prompts, of thoughts, and illustrate to the model how to follow that, then the response from the model is much better. So that's just a few, the main ones, but there's a whole set of different ways of prompting the model. And that all happens at inference time. So that prompt is constituted and submitted at the moment when you query the large language model. And these are all context augmentation tools. RAG, chaining, it's all tools that augments the context just at inference, putting the right information, the right wording into the prompt before it's submitted. And the advantage of a gradient-free approach, again, is that you're not investing in a single model. It moves an enterprise to a stage where they can be model independent. Just to bookend this slide, I think something one wants to keep in mind is the ideal is to be the master of your own destiny. The ideal is to have your own model, preferably an open source model, which you just deployed into a private area, and all queries to that model it's only from you. Just an interesting story. I'm tempted to name the company, but there was a company a well-known company that announced that they've got an auto-learning system. So they've got a natural language interface, and this system learns continuously. And I asked for access to it, and I wanted to do research and write an article on it. And I started submitting information, to learn, to teach this model, and then just build my own little custom environment. What happened, all the information I entered was telco related, right? So it was SIM swap, upgrade, when's my next phone upgrade due? And it started generating NLU training data for me. And this data was company specific. It was company data that was coming through. So I got in contact with them and I said, well, you're blending data. Other customers' data is coming through to me. And in a sense, what happens with OpenAI, even though they say there's governance, it's still company data that goes to, or private data that goes to that large language model that is in essence shared. So something I like, and again, I think Moodley will again this afternoon show it, but what I like about Gale is that you can deploy a open source model in a no-code fashion and expose it via an API in a private environment. So it's my deployment, it runs in my environment. All queries that goes to that instance of that model is via my API. So there's a great sense of comfort in that. So just looking at the enterprise ecosystem, the other day we sat back we wondered what are the steps to make an enterprise generative AI ready? What are the requirements in the simplest form? And again, the wording, I think in the design process, the wording got jumbled up. But the first step is to have no code access and experiment with the best performing foundation models. So there are many foundation models. People started using foundation models instead of large language models, just because models are becoming multimodal, and it's just not just one modality. So that's why they refer to foundation models. So people need to have no-code access to experiment, to deploy and experiment with the best of the foundation models, especially if it's open source models. There are so many studies that shows how to leverage open source models. And especially via RAG, it's been proven that various open source models perform as good and slightly better than that OpenAI's models. You know, if you leverage in context learning. The second thing is to connect those models with enterprise data and have guardrails you can manage. So you need to have knobs and levers to manage the guardrails, to test it as well, and you need to have the confidence to connect your data to those models. The third step is to build powerful AI apps to power their enterprise systems. I mentioned yesterday we did a survey on LinkedIn just to understand what are the use cases for generative AI. And what stood out was obviously customer service, customer care. That was high on the list. But something that came through in the comments was to automate processes. So people wanted a no-code, and that's what came through on LinkedIn. People wanted to have a no-code environment where they can build processes easily, which they can run to automate a process or a procedure in the enterprise. Something else that came through was that individuals want to have something one could call disposable automation, where you don't have to invest too much time and too much money in automating a task, and then afterwards you can dispose of it, so or not make use of it. So there's a need now. You build a flow or a piece of automation, you make use of it for a few months, or a day or a week, and that's the end of it. So these are the three steps, and this all needs to be in one controlled ecosystem without data flowing in and out. So basically, there are enterprise systems, there are AI agents, pipelines, prompt chaining, and then you want to have your guardrails. Then you have custom models, commercial models, open source models, but you really want all that data to flow through the guardrails and, in a sense, scan the data and remove anything that's inappropriate or anything that should not go to the model. There are obviously two sides to it. So it's the data that's input, and it's also the data that's output. So you want to scan the data that goes to the model, but also scan the data which the model returns. And as we saw with that previous example with RAG, how the RAG system was prompted to give email addresses and phone numbers. There are numerous examples in the news where people try and hack a conversational user interface and get the large language model to misbehave or to return anything that's inappropriate. Basically, the 5 layers, there's a source of truth. This can be core systems, external data, unstructured data. I think the part of that excites me most is the unstructured data portion. There's huge value in unstructured data, especially if you think of the contact center scenario. There's so much conversational unstructured data, and hence why I started previously with the data discovery portion. I think a while back it was referred to as dark data, but the whole idea that if you have a data discovery tool, you can discover the unstructured data, create structure from that, and move to the process of data design. So next step is the data layer. Then is the data studio part where the data can be developed, manipulated, cleaned. the fine-tuning portion, and then the app flow. And I think this is how an enterprise solution most probably will come together. Just the way Kore implemented data governance, and I got this from the Gale user interface. So this is these are 6 of the guardrails that's implemented, but there's already quite a bit more. So what I like about this is that each of these guardrails can be deployed individually, or they can be deployed, in any configuration you would need them. You can read the description of each of these guardrails, and each of these guardrails has got a test interface. So you can configure them, you can use regular expressions. If you want to write something more pro code, you can do it. And for each of these scanners, I would like to call them, you can create a little formula, a little form which is custom to your implementation. And then you can run different tests on that guardrail, and these scanners will ensure that whatever is input to the large language model is scanned, whatever is output is also scanned. So obviously I think the most common one is to anonymize data. I think anonymizing data is a very difficult process. It's something I discovered when I worked with Vodafone. We created a custom ASR acoustic model, and the moment you try and anonymize data, especially for training the model, you lose quite a bit of context. So that's why I like the approach of Gale, where you can write little routines and you can test to what degree you anonymize and to what degree the data loses context. Again, also banned topics. Obviously, there are conversations you do not want people to have with your bot, or the bot respond on that. Prompt injection, again, back to that example I had of RAG, where people ask different questions to retrieve personal information or any private information. Toxicity, for me, toxicity, and that's something also I learned when we implemented Toby at Vodafone, was that people vent, and there's toxic input to the chatbot, but the last thing you want is the conversational user interface to respond in any ill-mannered or any unwanted way. Bias is something that's perhaps more difficult to implement, and it varies from region to region. And also relevance. I think relevance, that's something chatbots suffered from in the beginning, especially where the response was not relevant to the user input. So there's also something in large language models called alignment, where you want to align the model's output with the user's input and the user's expectation. So relevance just ensures alignment, and to ensure there will be relevance is to, again, make use of in-context learning, and then make sure you submit the contextual reference with each time you run inference. Right, that's it from my side. And again, that's the code if you want to join our webinar when we officially launch XO 11. I think if there's any questions, you're welcome to ask now. You're also welcome to catch me afterwards. Thank you very much.